Welcome to our next edition of the free monthly webinars that we host here at Herzig Engineering. Today we're going to talk about electrical safety mistakes and how to prevent them. There are a lot of really common things that we see place to place and industry to industry that across the board it seems like the simple things. But in reality, they can be the difference between someone going home that day or not. So these mistakes are, generally speaking, pretty easy to fix, but there should be a change in culture and mindset to help prevent them in the future. But I'm getting ahead of myself. Today we're going to talk about the NFPA 70E. There's an informative Annex Q that you can look to, and it talks all about human performance and how it impacts electrical safety. We're going to very briefly go over that, but I mostly just want to highlight it for you to go back and read through later because it's only a half-hour webinar, so trying to be conservative on our time. Then we'll dive into what those common electrical safety mistakes are and the simple ways to address them. So like what actually should be happening versus what commonly does. And then we'll get into preventing them in the future. So from top down or from reorganizing your electrical safety program, how can we prevent these common issues in the future? And for whatever time we have left, we'll open it up for some Q&A. My name's Caitlyn Wininger and I'm with Herzig Engineering. It's been a little while since I've done a full intro. So my background is in electrical engineering and I'm a certified electrical safety compliance professional through NFPA, which basically just means I spend a lot of time in this book and they gave me the stamp saying, yes, she does. So we can definitely go through any questions or discussions that you might have today over this topic or any of our previous ones. You can always feel free to reach out. There's a whole team of knowledgeable people here that could help. But diving right on in, we're going to look at the informative Annex Q, which is the Human Performance and Workplace Electrical Safety Informative Annex. So real briefly, I just want to make sure everyone's on the same page. The NFPA 70E is the standard for electrical safety in the workplace. It was created back in 1979 as an aid for OSHA to implement safe work practices consistent with what the National Electrical Code requires for installation and what OSHA requires for workplace safety. So this kind of bridges the gap there and gives you the how and a little bit of the why behind what's required. So it's very important to be able to reference it. I'm going to go ahead and launch a poll here real quick. Do you have a copy of or access to the NFPA 70E? So there should be a poll that's popped up for you now, and the answers could be yes, that you've got a physical copy, or you've got that NFPA link subscription, or you just know how to get it for free online through the NFPA website, or no, and you need to get that. So select your answer and go ahead with clicking submit so that we can get those recorded. Looks like I've got about half of you submitted your response so far. And notice that I didn't have any answer that says no and I don't need one, because if you're on this webinar, there's a reason, so you probably need access to it. All right, I'm just going to give another couple seconds and then close it out. Okay, so a lot of people do, and for those of you who don't, well, guess what? I'm going to show you how. When it comes to, make sure my screen's sharing again, accessing the NFPA 70E, you can actually get free access online through their website. You just sign up for a free account, and then you go find the codes and standards list, open up the code or standard that you're looking for. The one we're highlighting right now is the NFPA 70E. You scroll down a little bit on their website, and there's this option right there for the 2024 edition to have free access. So you click that button, it'll prompt you to log in. Again, got to make that account if you haven't already. It's free to have. Or you can sign up for the NFPA link, which is a subscription service where it allows you to have all of those codes and standards that they've uploaded, but it's a little more flexible. So you can search it, you can highlight, you can tab things and bookmark them and come back for future reference. It's a lot easier to navigate on the full platform, but if nothing else, the free access will get you just that, access. So you can flip through page by page, or if you know what page to go to, you can type that in and go to that direct page. It's not searchable. You're not highlighting stuff, you're not bookmarking it, but you can read it. So there's no excuse. You should have access to what this book says and be able to implement them, even if it's going to take you an extra step or two to do that. All right, I digress. Whenever you go into, NFPA link or free access, or you get that good old-fashioned hard copy, we're going to flip to Informative Annex Q. So for those of you who have it out in front of you right now, there you go. You've got time to do that. But I'm going to highlight just a couple sections. First of all, I just want to point out what this is for. So Q.1, first of all, I just want to say informative annexes, backing up, are not actually a part of the requirements of the NFPA documents, but it is for informational purposes, and they help support and explain and expound upon and or give resources to implement safety-related work practices. So no, you don't have to implement Informative Annex Q in your safety program directly somehow, but it is a really great resource, just like any of the other annexes. So it says that this annex introduces the concept of human performance and how this concept can be applied to workplace electrical safety. Mind you, electrical safety is so key in regarding to human performance, because if something goes wrong, whenever you're working on troubleshooting, installing, turning things on and off, whatever, if something goes wrong in that electrical installation, possibly because of a human error issue, it could hurt or kill somebody. So workplace electrical safety and human performance really do go hand in hand for all of your qualified persons and even your unqualified persons. We're going to get to that. So human performance is an aspect of risk management that addresses organizational, leader, and individual performance as factors that either lead to or prevent errors and their events. So the object is to identify and address the potential for human error and its negative consequences on people, programs, processes, the work environment, organization, and or equipment. Notice that equipment is listed last. Still there. Worst case scenario, the equipment goes boom and no one's in the area. You still have to replace the equipment, but God forbid someone's standing nearby. So how do we do that? Well, first off, we have to understand the principles of human performance and why human nature leads to some of these issues and how to approach them. So the principles of human performance, first and foremost, people are fallible. I always say in my trainings, hate to break it to you, record scratch for some of you out there, you're not perfect. No matter what your mama may have told you, you're not perfect. And neither am I, and that's okay. We're unique, we're individuals, but we're not robots. We're gonna make mistakes. Even the best and the brightest and the most practiced of us out there make mistakes. And we have to stay humble enough to admit that of ourselves and our coworkers. So error-likely situations and conditions are predictable, manageable, and preventable. When you look at electrical injury, fatality, non-fatality, all those statistics, and then you go try to find the stories behind them, what you're going to notice is that, honestly, most, if not all of them, are preventable. And hindsight's 20/20. That step right there getting skipped, or that pressure getting put on that person, led to this incident. So it's predictable. And it's manageable, meaning if you can stop and think about those precursors ahead of time and work to mitigate them out or manage them out, then it does become very easily preventable. But that's a huge culture shift that we're going to be talking about as well. Individual performance is influenced by organizational process and values. Again, going to that culture. It's kind of a hot button term right now. Everybody says culture this, culture that, but it is true. And it speaks to the identity of the organization and the people within it. It cannot just be fancy slogans on posters throughout your facility. People, especially in leadership and those more seasoned to your work processes, have to exemplify that even whenever they think no one's looking, because I'm going to bet somebody saw it. People achieve high levels of performance largely because of the encouragement and reinforcement received from leaders, peers, and subordinates. So again, it's top down, bottom up, left, right, all around. Everyone has to buy into this to make it work. And incidents can be avoided through an understanding of the reasons mistakes occur and application of the lessons learned from past incidents. Now, that last one kind of goes to maybe a root cause analysis. If you have an incident or close call and you're doing that root cause, human performance is a factor in it, but I will say rarely, if ever, is it truly the bottom line root cause in the moment. Maybe it's an issue of planning or poor design, and so that could could tie to human error or human performance on that end of things, but rarely is it an in the moment. Human performance is the main and only reason that that issue occurred. There's usually other factors, but it is such a huge element to it. So if we can get our people, selves included, truly engaged and bought into this idea of electrical safety and avoiding those incidents from our perspectives and calling it out when we see it, it can lessen a lot of that risk. So we're going to talk a little bit more about informative Annex Q, not going to pull too much from it for the rest of this because I just want to get to some real scenarios, but it does point out some basic error precursors. What are the demands of the task? What's the work environment? Who actually are we talking about? That is very important. And just in general, no matter who you are, there's an element of human nature. And ways to help address those four main precursors are listed on the right there. I'm going to pull up the table from Annex Q later that kind of give more details on each of those bullet points, and we'll talk about them as ways to fix these potential mistake areas. But for now, I'm just giving you a preview. Pre-job briefing, job site reviews, post-job reviews, procedure use and adherence, self-check with verbalization. That takes a lot of humility to start if you're not used to that. Three-way communication, stop when unsure, flagging and blocking. So those are the ones that we're going to be looking at today. If my computer will respond. Okay, common electrical safety mistakes. So there's top 5 common electrical safety mistakes that I'm going to look at. First and foremost, working without proper PPE. How does that happen? Well, there's 3 main reasons. First of all, maybe they don't even realize PPE is needed because, well, I'm not doing energized work. Okay, well, let's look at this. When is electrical PPE needed? If there are exposed conductors or circuit parts, then electrical PPE is a must. Even to verify absence of voltage, troubleshoot, visually inspect, perform infrared scans, anytime you're crossing those boundaries, the people in those hazardous areas need to be protected if it's exposed. Now, even establishing an electrically safe work condition requires verifying absence of voltage. You're going to wear PPE during that because we don't want to assume it's off and then turn out it's not. If there are no exposed conductors or circuit parts, a lot of times people just totally disregard. Doors closed, covers on, no problem. Do your risk assessment. Sometimes what you're doing and why you're doing it could end up with exposure to those hazards, especially the arc flash hazard, because if it happens behind that cover and it's strong enough, it's a big enough event, it could blow covers off. We've seen it. We've seen videos, right? So PPE might still be determined necessary depending on what you're doing and why you're doing it. But definitely anytime there's exposure, you're crossing the boundaries, qualified people need to wear the proper PPE. Now, the other reason why they're not wearing the proper PPE is maybe they just don't know what it is. Maybe they're missing elements of it, or they go for that 40 cal suit every time and they get tired of wearing it. So they're like, oh, well, for this real quick, simple task, I'm just gonna real quick, don't mind me. I'm just gonna, all those little phrases, huge red flags, and definitely speaks to a human performance issue. Gotta have that self-discipline to stop and say, what PPE do I need? Do I have all the elements? And are they in good working condition? So again, that's the other thing as far as working without proper PPE, the keyword in that part being proper. Is it rated properly? Is it maintained well and in good condition? So all of those things have to be addressed. That's number 1. The second most common electrical safety mistake is skipping the risk assessment altogether. Even if you're really good about making sure people wear the PPE every time, anytime there's a possibility of exposure. Fantastic. What else? PPE is the bottom of our risk control hierarchy. What else are you doing? So thinking about risk assessments, yeah, you have to identify the hazards, but then you still have to assess the risks, likelihood and severity, and implement the risk controls according to the hierarchy of risk control methods. All of this is done in your job safety planning and briefing step. So, poll question for you guys. Do you have job safety planning and briefings for electrical tasks specifically? So, yes, you implement job safety plans for hazardous electrical tasks. Hint, hint, that means anything 50 volts and greater. Yes and no. We have them, but don't use them consistently, or maybe not for all electrical tasks. Maybe the higher hazard stuff. So that's that middle yes and no answer. Or no, or you're just simply not sure about job safety plans for electrical specific tasks. So click on your response and go ahead and click the submit button so that I can see what we're working with here today. Awesome. Got about half of you responding here, and definitely is eye-opening because I think a lot of people look to PPE. I will say, I think a lot of people look to that personal protective equipment and then they stop there. But we do still need to have job safety plans because there are additional steps there. And that kind of speaks to a robust safety program too, because risk assessments and job safety plans go very closely hand in hand. You're going to look at the type of work needing done, the condition of the equipment, the qualifications of the worker, the various hazards aside from electrical, although that's our main focus, the severity of those hazards, how bad would it be if it were to go wrong, the likelihood of injury, which goes into condition of equipment and what you're doing and who's qualified to do this, and what are you going to do if it all goes wrong. That emergency response plan is going to have to be a little more specific than just your general emergency response, because whenever you're talking about electrical emergencies, there are just simply additional steps. Sometimes we're talking about someone being locked on or hung up on a circuit, and your general emergency response plan is not going to address that. You have to know how to get people out of those hazardous areas without causing potentially multiple fatalities. So just a little side tangent there. When you're talking about risk, I said it a moment ago, but it's likelihood and severity, right? How bad would it be if it went wrong, and how likely is it to go wrong? They're not one or the other. So don't look at this and go, oh, this task, so improbable or remote that anything's going to go wrong. I'm fine. How bad would it be if it did? Even if it's unlikely, how bad would it be if it did? Well, if it's a significant or catastrophic issue, you're still going to have to take some action. You're still going to have to reduce your level of risk with some of those risk control methods, and vice versa. And remember, PPE is the last line of defense. It is the bottom of the hierarchy. You're going to have to use that in conjunction with the previous 5, but workers shouldn't stop at grabbing PPE. So go back and think about those risk assessments and your job safety plans. How can you implement more of these controls earlier on in the process? Preferably some of this done before the worker ever approaches that equipment. Okay, so we've got working without proper PPE, skipping the risk assessment. The next most common electrical safety mistake that we've seen is simply ignoring the arc flash labels. You get it done, get the study performed, labels are in place, you think, great, we're good to go. Check that box, fantastic. Yeah, okay, do they know how to read them? Because if they don't know how to implement the label information, they're not going to bother reading them. So having proper training where you're going through and explaining, here's the results of the analysis, here's what's PPE you're going to need, here's the boundaries, this is the equipment name and that date, how old is this study? Knowing how to read each of those elements and what it means to them individually at the moment they're about to do that task, whatever it is so very important. These labels, you have to have them for compliance, right? OSHA wants you to give people the information needed to keep themselves safe. The National Electrical Code has been very specific in the 2026 edition that you gotta have a specific label, not just generic, oh, caution, warning, there's a hazard here. No, what is the hazard? How bad is it? What are those boundaries? But having the label, personally, hot take here, is completely useless on its own. People have to know to read them and what to do with the information. So training over that, what the different levels are, what to do if it's a danger label versus a warning label, all of that needs to be discussed thoroughly so that people stop ignoring the labels that are there. And another reason this could happen is maybe they're overlooking them. We're in a very label and sticker happy society. So there's stuff everywhere. There's labels and signs and stickers and flashing lights and all kinds of stuff. Qualified people have to know what to look for and be constantly scanning for the type of label that you have on your equipment that tells them the information they actually need. And if you have that collage of labels and it looks like it became a middle schoolers art project at some point because there's so many stickers there now, maybe it's time to go clean some of those off. Figure out a better way to organize that information and or remove the stuff that's not needed on a regular basis, put it in a binder, or again, just organize it, make it a little cleaner for people to figure out what do they need to see. Because if you don't know how to identify where labels are on equipment, it's pretty easy to forget and overlook them. Okay, so we're working through our list here. We got 2 more common electrical safety mistakes. Number 4 being assuming that the equipment is de-energized. I hinted to this earlier, but it is a big, big issue. Just turning it off and putting a lock on it does not mean it's off. It does not mean it's de-energized, which really bugs some people whenever I say that, but it's true. All electrical conductors or circuit parts shall be considered energized until verified to be de-energized through the process of achieving what we call an electrically safe work condition, which, if you break it down, is really 8 steps with an assumed step that you're going to be putting on PPE and boundaries and doing your job safety plan before you start this process. So it's going to be qualified persons determining the sources and opening the disconnects, doing visual verification as possible, releasing stored electrical energy, releasing or blocking stored mechanical energy, and applying lockout tagout. And a lot of times that's where people stop. They're like, okay, locks and tags are on, let's get to work. Step number 7 is so critical. Live, dead, live. Do your triple check, make sure that it actually is off, and then if necessary, you're going to apply temporary protective personal grounding equipment. But that step number 7 really is so pivotal. And this is the step, even if you know you need to verify absence of voltage, a worker might not do it thoroughly, may not actually do all the elements of step number 7. So if you ever see someone locking out equipment and then they grab their meter, and let's just say that they're wearing their PPE and have their boundaries, so everything else is doing well, everything else is implemented properly, and they get their meter out and they put leads on equipment, and they're like, okay, yep, it's 0, and they start to doff the PPE, they've just skipped 2 to 3 steps because you're supposed to check at each point of work. So A to B, B to C, A to C, A to ground, B to ground, C to ground, all the phases, where they're actually working, and check that their meter is working itself. So on a known voltage source, they have to make sure the meter is reading properly. That's why it's called live, dead, live. That's a simple way of remembering. I have to go find a known source that's live and energized. My meter reads what I know it's supposed to. Then I'm going to go check phase to phase and phase to ground at each point of work. Hopefully all of that equals 0. Sometimes it doesn't, hence the need for the PPE and the boundaries. Don't assume. And then go back and make sure the meter is still working. Okay? So this issue of thinking something's off when it's not is still so prevalent in a bunch of industries. Huge red flag if you see people verifying, quote unquote verifying, absence of voltage with the little pen testers, little voltage presence indicators that light up or buzz. They are presence indicators, voltage detectors, not absence of voltage measuring. So you have to actually get a meter that can tell you there is no active voltage. You know, there's maybe some trace. There's no, hazardous voltage left. Not that, well, maybe the pen tester just wasn't picking it up that time. All right, so working without proper PPE, skipping the risk assessment, ignoring arc flash labels, and assuming equipment is de-energized are very common electrical safety mistakes. The one that I think is going to surprise some people, inadequate training for non-electrical workers. We're not just concerned about electrical safety for electricians and maintenance techs and HVAC and all your electrical crews. Non-electrical workers are at risk as well, and they should be involved in your electrical safety initiatives. So whenever we look at the difference between qualified versus unqualified, qualified person is the people that you should be coming to mind, electricians and maintenance techs and HVAC and the people who actively work on anything 50 volts or greater as part of their job. They need to demonstrate their skills and knowledge of the equipment they work on and receive safety training to identify the hazards and reduce the associated risk. If someone doesn't meet this definition, they're not qualified. and they shouldn't be exposed to those electrical hazards. So unqualified workers need to know they're not the ones opening electrical closures or working near exposed electrical components. This includes outlets and light switches and light fixtures. Don't be letting, just because you're short of staff, don't be letting people who don't have the qualifications, the training and the auditing, perform these quote unquote simple electrical tasks. Make sure it's qualified persons. Because even if it is a simple task, it's still hazardous. So they're not going to have the PPE, they're not going to have the know-how and the knowledge or the approval to do so. But what do they need? Even if they have no responsibility for electrical work whatsoever, they still need to be trained in and familiar with whatever is needed for their safety. Most of the time, I would say it's just awareness that there is a hazard present, potentially, and how to avoid it. So how do they identify where hazards are and avoid them appropriately? That's going to be my main focus whenever I talk about unqualified worker training. You might be sitting here going, yeah, okay, what does that have to do with anything? I thought we were talking about electrical safety in the workplace and performance for electrical tasks. And well, yes, but if you've never really considered the breakdown for qualified versus unqualified workers, electrical occupations versus non-electrical occupations, looking at this next chart might surprise you. So according to the Electrical Safety Foundation International, which they have so many good resources on their website, so I highly encourage you to look at this. When we look at electrical fatalities in the workplace, non-electrical occupations take 70, actually more recently it's more like 75% of fatalities whenever you add in the last couple of years. 70 to 75% of electrical fatalities in the workplace are non-electrical occupations. What does that tell you? They don't know better. Maybe they're jumping in and doing things that they're not supposed to because they're trying to be helpful. That's pretty common. Or they're walking around their work area thinking, I'm just doing what I'm doing, not at all concerned about an electrical task. And because of proximity to where the electrical work's being done, they're getting hurt or killed. Or there's an issue with the equipment that they're working with. So tools or equipment, machinery, there's an issue with that, and they haven't been taught how to identify or do inspections of any sort. And so they're accidentally touching or creating problems for that electrical system that's causing them to get hurt and killed more often than the electrical workers. That's crazy to me. So yeah, we have to make sure they know how to identify and avoid these hazards as well. Even simple stuff like extension cords, teaching everybody how to inspect an extension cord, not just the electricians, could actually save someone's life. I'm not even trying to be dramatic here, guys. Checking extension cords can save your life, okay? But the arc flash hazards and the more extensive hazards that go with the larger installations, the big disconnects and panels and switchboards and switchgear, still train to a reasonable level on those topics as well. Because if nothing else, they have to know how to respect those boundaries. If there's a barricade set up, caution tape, cones, danger tape, whatever, and people aren't respecting it, what good is it? So they have to know why it's there. You know, there's no moving parts or flashing lights or sounding alarms whenever you open up a cabinet. So unless they're taught that means danger, you see those metal parts, that means danger, how would they know? They wouldn't. It's not like an instinctual thing where you see a saw blade spinning and go, I shouldn't touch that. Everything's supposedly, hopefully, quiet and still and not glowing and on fire. No, it's just sitting there. To the untrained eye, that's not hazardous. It's no big deal. When in reality, it could hurt or kill someone from 5, 10, 15, 20 feet back. So again, if nothing else, identifying the hazards and how far back they need to stay should be a heavy emphasis in your unqualified worker training. All right, so some general practical steps, and I'm gonna just fly right through this because I realized we're already at the top of the hour. Going back to that table in Informative Annex Q, where it had the error precursors and the human performance tools, it breaks down some more details than I'd had earlier on that bullet point. So task demands, if you're in a hurry, there's a high workload and need to rely on memory or trade knowledge in like a tribal way, just word of mouth, whatever, then documenting step-by-step procedures and having pre-job briefings to make people slow down and stop before they work will go a long way. It'll work wonders. Due to time constraints, I'm not going to walk through every single thing on this slide, but what I will do is stay on longer, and I can always go back to it in case anyone wants to. But just to summarize here, what you can start on today, have a system study. Make sure that you can identify what you're working with and what you're trying to protect people from. If you don't know, it's a shot in the dark. It's a guess. You might be overdoing it. You might be underdoing it. You really just don't know. So have a complete and accurate system study done. Then train both qualified and non-electrical, unqualified workers about what they need to know for their safety. Update your program to make sure that it includes effective job safety plans and those human performance tools and more risk control methods than just PPE. And then verify that your qualified workers are actually qualified. They are not, again, infallible. They're not fallible. Anyway, they're not perfect. That's what I'm trying to get at. They can forget things, become complacent. Again, even the best of the best make mistakes. So verifying on a regular basis, at a minimum every year, you need to make sure you're doing those audits, evaluations, watching them work, retraining every 3 years, all the nine yards that you need to do there. If you need help, of course, we can get you covered. We have a plethora of services and options and even customized solutions to make sure that whatever implementation in your workplace is being done is actually compliant and practical. Sometimes people get off in the weeds because they want to make sure that they're compliant, but in reality, we can simplify some things, get you covered, and make it easy for the workers to implement. I digress. Understanding what's required and why is really important, not just to achieve compliance, but more importantly, to keep everyone safe. And I think most everyone who's spending their afternoon listening to me talk about this will agree. So I really appreciate your time today, and I'm going to open it up for any questions or comments, concerns, stories, anything that comes to mind. Otherwise, you can always reach out to us and we'll help you with anything you might need or answer any questions at a later date. I hope you guys enjoyed this. I hope it was helpful. You can go back and watch all of our previous free webinar recordings on our YouTube channel, and that way you can just keep learning, keep refreshing. All of the topics we covered today, as far as the common electrical safety mistakes, we have other webinars that go really deep into each of those topics individually. An hour for this, half an hour for that. So if you want more about how to address those top 5 common issues, go check out our YouTube channel. You're going to find a lot. So anyway, thank you so much, everybody. I hope you go home safely and have a great weekend and a happy Thanksgiving.